Alright, now we're taking what we just did, recursive and explicit rules, we're applying them to real life situations. So this learning target says I can model real world situations with the arithmetic, remember that just needs the plus rule sequence. Let's get right into it. Alright, our goal is to write one recursive and one explicit rule for each of these. Alright, and then we're going to use the rule to answer the question. So let's start with recursive. And honestly, I don't very often use a recursive routine to answer these questions because explicits, which I'm going to put over here, are usually a better method. It allows us to find any term in a sequence. So it says there are 19 seats in the first row. Well, I'm going to underline that, and I'm going to say that in the recursive. I'm going to say, hey, my first row has 19. Alright. And then it says each row after the first one has two more. So we're going to say that. Hey, to find my next term, I have to take the previous term, which is going to be my next term minus 1, and I'm going to add 2 to that. And we're going to say for, this is a recursive routine, we've already talked about the first one, we're going to say for 2 to 13. Those are the rules. And we'll say it like this, I guess, for, I'm going to erase that 13. We'll say for n is greater than or equal to 2 and less than or equal to 13. That gives us 13 rows, the first all the way up to the 13th. Alright, let's come over here and do a recursive. Alright, so we'll say f of n is equal to our start, which I believe it says is 2, plus our rule, no, our start is 19, I apologize. Our start is 19, plus our rule, which is 2, to the, and on this one I'm going to say n minus 1, because the first row had 19 in it, and we don't want this to change until I get to the second row. So we have to back this rule up one. And that is going to be for n is greater than or equal to 1. And I'm going to stop with that. You know what? I should have probably made this go on forever, but it doesn't really say we stop in the 13th row. Maybe there's more than 13 rows. So I should probably erase this part right here. And I think I'll just mark through it right here and leave this greater than 1. Now if I want to find that out, let's plug it in. Let's use the explicit rule. What if I do f of 13 is equal to my start plus 2 times the 13 minus 1. That means I started with 19, and that has changed 12 times as I've moved up 13 rows. So that's 19 plus 24, which gives me 30 or 43 suits right there. And there it is. Let's do this next guy. All right. Let's go ahead before we read. I'm going to write recursive here. Let's underline that, and let's write explicit over here. And let's see what it says. Alright, a student has a part-time job and borrowed money from the parents to purchase a bike. The graph over here shows how much they... Okay, so she's paying off money, right? And the amount will only be shown for the first 5 weeks. And how many weeks does it take to pay it off? Well, let's look at our start. Let's do recursive. So it looks like 0 week, so we'll say f of 0. And it looks like she started off owing 800. And let's find out what the difference is. So anytime I want to get a difference, I can take any term, like the first term, and subtract the term in front of it. So it looks like the first term looks to be 750. And we realize they started, the 0 term was 800, so my difference is minus 50. That's my change, that's my add rule. So I'm going to say, hey, take the previous term, and we're going to subtract 50. And until it's paid off, so we know that n is going to be greater than or equal to 1. Not quite sure how far it goes. All right, but we will. For my explicit function, we'll say f of n equals, well, what's my start? My start was 800. And then my rule, minus 50 every term. And since we started at 0, my term starts right here at 0. All right. So I don't have to say a minus 1. And Let's find out when it's paid off. Let's find out when f of n is 0. Alright, so we'll say 0 equals 800 minus 50n. Subtract 800. Negative 800 equals negative 50n. And to pay it off, we divide by 50, and that's going to be 16. So it takes 16 weeks. Alright, let's do another. Alright, so I'm going to write recursive here again. Recursive. Hopefully this will fit. We got explicit. Again, that's just like a slope-intercept equation. Alright, so what does it say? Starting salary is $3.95 per week. That's our starting. We'll say that's, I don't know, I guess that's our first week. So we'll say f of 1 equals $3.95. And what happens? It increases by 45 a week. Wow, if that was a real job, it'd be awesome. If you could work forever, if there wasn't an end date. So we'll say, hey, to find out my next term, I take the previous term, n minus 1, and I add 45. There it is. For the explicit, f of n is equal to my start, 395, plus 45, and since we started with the first term, we'll say, 45, n minus 1. I think that's where we're at. Let's see what it wants. It says, the last week of camp, you make $710. So how many weeks does camp run? Well, if in this week we make $710, $395, it'll tell us how long, that's a plus sign, isn't it? It would take us to get there. So if we distribute, 710 equals 395 plus 45 n minus 45. Let's bring it over here. 710 equals, what is that? 350. If I subtract these guys right there, 350 plus 45n, subtract 350, was that 360 equals 45n. Divide by 45, we got n is 8 weeks. Tells us how long it would take you to make that much money. In addition, since that's the last week, it tells you how long camp is. We got a little bit more time, so I'm going to go ahead and at least start this guy off. I'll let you solve it. So we'll say recursive. And again, remember, these are just starts and rules. I would recommend that you guys look back at those notes that we gave when I first started about recursive routine and try to compare how we're writing these equations to what that original formula was. So this recursive routine is talking about grocery carts, and we know they slide into each other. So that first one's pretty long, and it says as you add grocery carts, they looks like they grow. Let's find how much they grow by. Looks like if I can find my difference, I can take any term like 50 and subtract the previous term by 38, and I could pick any of those terms, 60 divided minus 52, or 74 minus 62, or 86 minus 74, and my difference is always going to be 12 no matter which one I pick. So this is a common add rule, which is what makes an arithmetic sequence. Alright, so on this one I could say, hey, you know what, f of 1 equals 38, and to find my term I take my previous term and I add 12. And let's go ahead and say for n is, well, I guess we'll say n is greater than or equal to 1. Can't have less than one cart. And for my explicit, I'll say f of n equals my start, 38, plus my difference, how much it grows by, every time I change. Remember, we started with 1, so we don't want that first one to add 12. So we put a n minus 1 there. If I put in 1, 1 minus 1 is 0, and that kind of cancels off, which tells us our first rule would be 38. My first cart is 38. Now we just plug stuff in. So it says, hey, how about 25? Looks like I'll finish this with you. So if I get f of 25, I got 38 plus 12 times 25 minus 1, which means it has actually grown by 12 inches 24 times. And if I plug that in, f of 25, this in the calculator is going to give me 326 inches. And there it is. We'll practice this in class.